Hello, my name is Aiden Rabzadeh, and this is part 1 of the binary game. The purpose of the binary game part 1 is to monitor the outputs of a switch bank, assemble the state as an 8-bit binary value, and shift it into the Moreland bar graph v3, which is broken down here to display the value. Here are the parts on screen. Right now, the Nano might seem like a black box that takes in the states of these switches. For example, if they were 0, 1, 1, 0, 0, 1, 1, and magically shifts them into the register and onto the bar graph. But hopefully by the end of this video, you will understand its inner functions and how everything works. First, let's talk about how the 74HC595N shift register works. Here is its 16-pin arrangement. To make this function normally, the output enable pin, which enables the outputs of the 595, is low, and the shift register clear is high to prevent it from clearing the outputs. The most important pins on the 595 are SER, serial/data input, R clock, register clock/latch, and SR clock, shift register clock. SER is used to send data into the shift register 1 bit at a time. R clock to latch/copy the outputs of the internal shift register to the output pins when high, and SR clock as the positive edge triggered clock for the 595. Every time the 595 receives a clock pulse, the contained bits are shifted left 1 position, and QA takes on the state of SER on the rising edge of the pulse. For this reason, having a consistent clock is crucial for the function of the 595. Now let's dive into the code. Here's my code for the project. First, I define latch, date, and clock to their respective pins. I initiate the serial monitor and set its speed to 9600 baud, and wait until serial acknowledges it is ready. This is the first for loop out of 2 used in the project. Basically, it will run 8 times. This is because S starts as being equal to 2, and it will continue running until S is not less than or equal to 9. Each time the for loop runs, 1 is added onto S. That means that since S is defined as an input every time the loop runs, this will declare digital pins 2 to 9 as inputs. Also after this, I am declaring latch, date, and clock as output pins. Now we get into the loop, the most important part of the code. Let's say, for example, the first switch is high. The high will carry through the switch and into the input pin of the Nano. This part of the second for loop assures it will only run until D is equal to 9. This part reads the state of pin D each time the loop is run, shifts the value left to match the switch number, and uses bitwise OR to create an 8-bit binary value, in this case 10000000, after the loop has run its course. Then it is printed on the serial monitor and shifted onto the 595 and bar graph. Thanks for listening, and I hope you now understand how this circuit works and translates this input onto the output of a bar graph.